Hi there. The purpose of this video is to explain to you what I want you to do to satisfy me with Project 6, Option 7. So let's navigate there and take a look at it. We're going to be dealing with a motor. It is specifically a DC motor, which means direct current. It's an electric motor. Okay, it's the type of electric motor that would be running, let's say, inside of a hard disk drive or an optical disk drive, like a DVD player, and let's say in a gaming console, the optical drive in that. It could be a DC motor that is controlling a fan or ventilation system as part of a furnace. So let's take a look at what we have right over here. Option 7. So here's a motor. Notice that it is actually now rotating, and this is a counterclockwise motion. Now, I'm just going to have this assembled and run. And you'll notice that when you'll notice if you just keep watching this, this is going to slow down. It's actually almost like coasting. And I wonder if this DC motors like this, there could be some sort of control here, maybe within e-vehicles, right? Electric vehicles. But notice it's actually noticeably slow right now. So what we have here is if switches 4 and 5 are open, the motor will freewheel slowly to a halt. Okay, and you can tell it's actually really slow right now. If switch 4 is closed, the motor will accelerate clockwise. So this is counterclockwise motion, all right? And clockwise motion goes around in a circular flow like this. Oh, look, this thing is almost stopped. If switch 5 is closed, which means there's a connection there, it's on, the motor will accelerate anti-clockwise, which is counterclockwise, just another way of saying that. If 4 and 5 are both closed, the combination should be ignored and the switches will remain in their previous state. All other switches 0 through 3 and 6 through 0 through 3 and 6 through 7 should be ignored. Okay, so you've got all of these instructions here. You've got a programmable logic, well, not a programmable, you have a controller here, a microcontroller that's programmable, and you have these switches, and 0, 1, 2, 3, 4, 5, 6, 7, which means there's 8 all in all, and you can see the pathways for the wires here coming from the outputs of port A and port B. You got inputs and outputs and all of this, and you can see it is also controlling the motor, okay? This is still going counterclockwise. All right, so now the question is, can you create a video that demonstrates, I know it already will, come to a coasting stop, but I would like you to demonstrate a video where you have it run. I'm just going to stop it here so that I can actually highlight this. Have it run with switch 4 closed, which means it's activated, and have it accelerate counterclockwise. Explain the coding that you do to get it to do that. And then here's another one. Switch 5 closed, it will accelerate anti-clockwise. So I want you to actually do your video where it is switch 4 and then recode it and make it switch 5, and then have switch 4 and 5 turned on and prove to me that it will just continue doing the previous state. So right now, 4 and 5 are open. They're not being used. The coding is right there. But why is it that when it runs, let's reset it here. And just make it smaller so we can see it all. Okay, here we go. Let's run it and let's speed things up. Look at this. Notice how it's just skipping over. It's skipping over the 4 set and the 5 set, but the none set is happening. So that's why it's coasting. Can you reprogram this so that we can actually have it do the 4? And then as it speeds up really fast, which would be clockwise, spinning like that, and then switch it to 5 and have it come back into the other direction and have it accelerate, and then have 4 and 5 open and have it basically not change from the previous state. I want you to copy and paste code, make it happen. All right, folks, this is going to be so cool. And you'll have this amazing control over a DC motor, and just pretend it's connected to an electric vehicle somewhere, right? And Some of the electric vehicles have 4 DC motors, one for each wheel, right? And you can just imagine the circuitry that would be involved in controlling those wheels with the right rotation, the motors with the right rotation, so that you're not tearing the car apart as it's going around a curb, right? Around a curve. And some of them only have one, and some of them have dual motors, right? So I want you to do this and pretend that you're an automobile engineer. Or maybe this has to do with heating and ventilation. Maybe you're controlling first and second stage ventilation. Maybe you're creating a negative pressure room or a positive pressure room in a hospital so that it can actually keep infectious diseases in the room, and so it doesn't cause the spread. Just your imagination will go. Why don't you see where DC motors, do a little search on DC motors and see how they're used in HVAC, in hospitals, in electric vehicles, and other applications, and see if you can make this do what I asked you to do, all through all of this right here. Okay? Have it do all of these right here for that bonus point. Thank you.